Hi everyone, myself Bhumika Sharma, student of 4th Sem Physics Honours. In this video, I'm going to talk briefly about Raman scattering and Raman effect. So, let's start. Raman effect and scattering. In 1928, Sir C.V. Raman, while studying scattering of light, the study in which he got Nobel Prize in 1930, found that when a beam of monochromatic light was passed through organic liquids such as benzene or toluene, etc., the scattered light contained other frequencies and in addition to that of the incident light. Such a scattering is called Raman scattering. The scattering of light from molecules with a change in frequency is called Raman effect. Now, let's consider this as a molecule, and this is an incident ray passing through the molecule, which is monochromatic light having the frequency nu naught. A single incident ray, while passing through the organic molecule, gets scattered into three rays, as we can see here. One having the frequency higher than that of incident ray, one having the frequency equal to that of incident ray, and one having the frequency less than that of incident ray. This is Raman scattering, this is Raman scattering, and this scattered ray which has the frequency as equal to the incident ray is known as Rayleigh scattering. Now, here I have made one experiment picture of Raman effect, that is, this is incident ray, this is Rayleigh scattering, this is anti-Stokes and Stokes-Raman effect. Let me explain this. This is the incident ray and it's passing through an organic molecule. When passing through the organic molecule, Rayleigh scattering, यहाँनिर मैले ग्रीन कलरले डिनोट गरेको छु इन्सिडेन्ट लाइटलाई र यहाँ रेलीलाई पनि मैले ग्रीन कलरले नै गरेको छु. Why? It is because their frequency is equal. As I've already told earlier that incident ray र Rayleigh scattering को frequency same हुन्छ अनि incident light को भन्दा बेसी फ्रिक्वेन्सी भएकोलाई मैले पर्पल कलरले डिनोट गरेको छु. यहाँनिर त्यसलाई भन्छ एन्टी स्टोक्स स्क्याटरिङ एन्ड जसको चाहिँ इन्सिडेन्ट लाइटको भन्दा कम्ती फ्रिक्वेन्सी हुन्छ त्यसलाई भन्छ स्टोक्स रमन इफेक्ट, जसलाई मैले रेड कलरले डिनोट गरेको छु. सो दिस इज द ओभरअल एक्सपेरिमेन्ट अफ रमन स्क्याटरिङ एन्ड रमन इफेक्ट. Raman observed that the spectrum of scattered light contains a line of same frequency as that of incident light, which is called Rayleigh line. This one. And the lines on the low frequency sides are called Stokes line. This one, Stokes line. And the lines on the high frequency side is called anti-Stokes line. High frequencies, this is this one, anti-Stokes scattering. Now, while talking about the intensity of these lines or that these scattered rays, Stokes lines are more intense than anti-Stokes line. जुन चाहिँ यो Stokes line छ यसको intensity चाहिँ यसको भन्दा anti-Stokes को भन्दा बेसी हुन्छ. Now, let's talk about the Raman shift. It is a new term for us, so let's understand what is Raman shift. It is nothing but difference between the frequency of incident light and the frequency of scattered light is known as Raman shift. That means यो incident light को frequency र यो तीनटा incident scattered ray को frequency को difference लाई नै Raman shift भन्छ. Now let's move to another part. Raman shift लाई नै continue गर्दै, let nu naught is frequency of incident radiation and nu dash is frequency of scattered radiation, then Raman shift, that is delta nu is given by delta nu is equals to frequency of incident light minus frequency of scattered light or ray. We know delta V equals to nu naught minus nu dash, that is the difference between the frequency is given by of frequency of incident ray minus frequency of scattered ray. Now, number 1, when nu dash, that is the frequency of scattered ray, is less than that of frequency of incident ray, then delta V, that is the Raman shift, will get the value of Raman shift in negative. That is, Raman spectrum is said to be consisting of Stokes line. This Stokes line, that is negative, which has the lower frequency than that of the incident light. And while looking in the second case, when nu dash is greater than nu naught, when the frequency of scattered light is greater than that of incident light, then we'll get the value of Raman shift in positive. That is, Raman spectrum is said to be consisting of anti-Stokes lines here, having the higher frequency than that of incident light. And in the third case, when nu dash is equals to nu naught, जब चाहिँ इन्सिडेन्ट रेको रेको फ्रिक्वेन्सी र स्क्याटर्ड रेको फ्रिक्वेन्सी चाहिँ इक्वल हुन्छ, देन डेल्टा V, that is our Raman shift will be equals to 0, since there will be no difference. Raman spectrum is said to be consist of Rayleigh line only. This one, Rayleigh line only. So this is a molecule, organic molecule, through which monochromatic light is passing and getting scattered. This one is anti-Stokes having the higher frequency. This is a Rayleigh line having the same or equal frequency to that of incident ray, and this one is the Stokes, that is having the less frequency than that of incident ray. I was talking about the intensity of these three. Scattered ray. As I've already told that the intensity of Stokes Raman scattering is greater than that of anti-Stokes Raman scattering. As I've already told that Stokes is more intense than that of anti-Stokes. In this graph, this is intensity versus frequency graph. As we can see here, the intensity of this Stokes Raman scattering is greater than or higher than that of the anti-Stokes Raman scattering, and the intensity of Rayleigh line is as same as that of incident ray. While comparing Stokes and anti-Stokes Raman scattering, what we found is that Stokes Raman scattering ko chai intensity बेसी हुन्छ as that compared to anti-Stokes Raman scattering. And while talking about the frequency, anti-Stokes Raman scattering has the higher frequency than that of the Stokes Raman scattering. So this was all about the brief introduction of Raman effect and scattering. Thank you.